السلام عليكم ورحمة الله وبركاته. يعطيكم العافية شباب وصبايا. Today we will talk about fluid mechanics part 2, which is from chapter 13 in our textbook. So the subject for today is about Bernoulli's equation. In general, Bernoulli's equation is a statement of energy conservation, which means if we are looking to this tube or this pipe, we can say the following: the work done on a fluid as it flows from one place into another place will equal to the change in its mechanical energy. So let me remind you, with the mechanical energy or the total energy, we are talking about kinetic energy and potential energy. But here, speaking of fluids, we are not dealing with masses, we are dealing with densities. So we will take, or we will have, three parameters. The first one, work per unit volume done by a fluid, which is P. Potential energy per unit volume, which is rho G Y, and kinetic energy per unit volume, which is 1/2 rho V squared. Therefore, Bernoulli's equation will be pressure plus rho G Y plus 1/2 rho V squared equals constant. So from here, we can get the following formula or equation: P1 plus rho GY1 plus 1/2 rho V1 squared equals P2 plus rho GY2 plus 1/2 rho V2 squared. Special cases, which they are two: either if I have a horizontal pipe, that means the initial height and final height equals to each other's, and therefore this term will equal this term and they will cancel out, then we will get the following formula. Second case, if the speed is constant, which means initial velocity and final velocity equals to each other's, and the kinetic energy per unit volume in the entrance and the exit equals to each other's, therefore we will get P1 plus rho GY1 equals P2 plus rho GY2. And please remember that we are dealing with entrance and exit, so we still talking about flow rate, which means you have to remember Q1 equals to Q2 and A1 V1 equals A2 V2, which is, as I mentioned before, the nozzle is connected to a horizontal hose. The nozzle shoots out water moving at 20 meters per second. What is the pressure difference between the nozzle and the hose? Okay, this question is about Bernoulli's equation. So the first step I would like to deal with is mark the hose as number 1 and the nozzle as number 2, as you can see here. Now writing the Bernoulli's equation, but from the question, the tube is a horizontal, so this term will cancel out with this term and you will get this one. Now the question is about to calculate the pressure difference between nozzle and hose, which means pressure of the nozzle, which is P2, minus pressure of the hose, which is P1. As you can see here, P2 minus P1, which is 1/2 rho V1 squared minus 1/2 rho V2 squared. But V2 is given, so we have to calculate V1. Now, at this moment, we have to go back to the flow rate, which is A1 V1 equals A2 V2, then calculate V1. So now V1 is known, V2 is known too, and the density for water is 1000 kilogram per meter cube. So therefore we can say P2 minus P1, which is 1/2 rho V times V1 squared minus V2 squared. And the pressure difference will be minus 150 kilopascal. Second example, water is flowing in a fire hose with a velocity of 1 meter per second and the pressure of 2 times 10 to the power 5 Pascal, or we can say 2 atmosphere. The hose is connected to a nozzle where pressure decreases to atmospheric pressure. There is no change in height. Calculate the velocity of the water exiting the nozzle. Maybe the first idea you will come up with, like, let us use the flow rate. Okay, A1 V1 equals A2 V2. We have V1, but we have nothing about the first area and the second area, or the area, the cross-sectional area of the entrance and the cross-sectional area of the exit. So we cannot use the flow rate or the continuity equation. Now let's go to Bernoulli equation. Bernoulli's equations says the following, but be careful. I have a horizontal pipe. Therefore, we can say P1 plus 1/2 rho V1 squared equals P2 plus 1/2 rho V2 squared. Now, the density for water known. One of the velocity is known. P1 and P2 are known too. So therefore, we can solve for the second velocity by taking P2 to the other side, then multiply by 2 and divide it by rho, then take the square root. You will end up with this formula. Now, substitute the velocities, pressure, and density. You will get the second velocity, or the velocity of the exit, or the velocity existing the nozzle is 14 meter per second. Third example. Water is flowing at rate of 2 meter cube per second through a horizontal pipe with a diameter of 1 meter. If the pressure at this point is 80 kilopascal, what is the pressure of the water after the pipe narrows to a diameter of 0.5 meter? Okay. As I mentioned before, I would like to mark I would like to mark one of the sections with number 1 and the second cross section with number 2. Now I have large and small sections, so I would call the following: the larger, which is number 1, the narrower or the smaller, which is number 2. Now to calculate the pressure, we are going to use Bernoulli equation, but be careful, we have a horizontal pipe, so we are going to deal with this equation. Now to calculate the pressure in the narrow pipe, which is P2, from here P2 equals to P1 plus 1/2 rho V1 squared minus 1/2 rho V2 squared. Now the first pressure known or given, the density of water, which is known, the velocity V1 and V2, both of them are unknown. But be careful, I have a key in the question, which is the flow rate. Now easy, I can say Q1, which is A1 V1. So from here V1 will be Q1 divided by A1, Q1, which is 2 meters cube per second, and the area we are talking about circular cross-sectional area, it's for tube, so it's gonna be by r squared, but the radius is unknown. What given here is the diameter, so you can say radius equals to diameter divided by 2. So substitute your numbers, you will get V1. using the same procedure to get V2. Now, V1, V2, density and pressure in the larger or the large side, all of them are known. So it's easy to say, okay, P2, which is equal to 31 kilopascal. If the average distance between the feet and heart in adult is 95 centimeters and the blood density is 1060 kilogram per meter cube, what is the pressure difference between the heart and feet? Let us assume heart is is number 1 and feet is number 2, or cross-sectional area number 2. Now Bernoulli equation, as you can see here, but be careful here, the velocity is constant or the speed is constant. Therefore, this term, the kinetic energy, with this term will cancel out. You will find P1 plus rho gy1 equals P2 plus rho gy2. Now, to calculate the pressure difference, which is between heart and feet, which is P1 minus P2, because I called or I marked or assumed the heart is number 1 and feet is number 2. So from here, P1 minus P2 will be rho gy2 minus rho gy1. Now, let me take rho g as a common. You will get the following formula. P1 minus P2 equals rho g delta y. Now, rho, or the density for blood, is given. G is known, which is 10 meters, almost 10 meters per second, or approximately 10 meters per second squared, unless if we told you in the exam or in the question, take G 9.8 meters per second squared. But delta y here is y2 minus y1, which is already given 95 centimeter, but you have to convert it into meter, which is 0.95 meter. So plug your numbers, you will get P1 minus P2, which is 10.07 kilopascal.